Welcome back, young math Padawans, to our lesson on properties of equality, part 2. The next property of equality we're going to look at is MPOE, or MPOE, and it stands for the multiplication property of equality. You need to multiply both sides, or all terms, by the same value to keep the equation true. Then there's DPOE, or DPOE, which stands for the division property of equality, and it states to divide both sides, or all terms, by the same value to remain true. Let's look at some examples. All right, starting with MPOE and a true equation, 10 equals 10. I'm going to divide my equation in half to fully separate the left side of the equation from the right. Now, multiplication works a little bit differently. To show multiplication, we use parentheses next to the number and put the number that we're multiplying by inside. We're multiplying the left side by 2. 2 times 10 gives the left side of the equation a value of 20. So if I kept everything as is, does 20 equal 10? No, this is a false equation because of the multiplication property of equality. To keep this equation true, I need to also multiply the right side of the equation by 2 so that we have 20 equals 20 and a true equation. Now 6 plus 4 equals 10. Put the line in to separate the left side of the equation from the right. And let's start by multiplying the right side of the equation by 2. 10 times 2 gives the right side of the equation a value of 20. Now here's my question. Are we going to multiply 6 by 2, 4 by 2, or both of them by 2? Let's see. Let's start by only multiplying 6 by 2. 2 times 6 is 12. Bring down the 4. 12 plus 4 is 16. Will 16 equal 20? Definitely not. This equation is no longer true. So that didn't work. Try something else. How about only multiplying 4 by 2? Okay? 4 times 2 is 8. And 6 plus 8, shoot, that's 14. Does 14 equal 20? Nope. Another false equation. There's only one thing we haven't tried yet. If we look at the definition of MPOE, it says to multiply both sides of the equation by the same value. That means I need to multiply the entire left side by 2. So that means multiplying 2 by 6 and multiplying 2 by 4. Let's see what happens there. 2 times 6 is 12. 2 times 4 is 8. Does 12 plus 8 equal 20? Yes, it does, which means now we have a true equation. You may have noticed that's why it says all terms in the definition of MPOE. When you're using multiplication of property of equality, make sure to multiply everything you see in the equation. Otherwise, it will not remain true. Final example with MPOE, 6 plus 4 equals 12 minus 2, which we know is true because they both have a value of 10. So if I decide to multiply the entire left side by 2, as we just saw, 2 times 6 gives us 12. 2 times 4 gives us 8. So the left side of the equation has become 20. And that should make sense because if you remember, 6 plus 4 is really just 10. So we want to show that we're multiplying the entire side by 2, and we should end up with 20. So now off to the right side. Which term am I going to multiply by 2? Am I going to multiply 12 by 2, 2 by 2, or both? If you said both, you are correct. Multiply the entire side. 12 times 2 is 24. 2 times 2 is 4. And 24 minus 4 is 20, making this a true equation. Time to look at DPOE, division property of equality. Line down the middle of my equal sign to keep the left side separate from the right. Now let's say I decide to divide the left side of this equation by 2. 10 divided by 2 is 5. If I keep everything as is, do I have a true equation? No way, Jose. 5 does not equal 10. So if I'm going to divide the left side of the equation by 2, I better divide the right side of the equation by 2 as well. 5 equals 5, that's a true equation. This equation, a little more complex, but still true. 6 plus 4 does equal 10. My line is separating the left side from the right, and I'm going to start by dividing 10 by 2, which means the right side of my equation now has a value of 5. Here's my question. Which term on the left am I going to divide by 2? 6? 4? Let's start with 6. 6 divided by 2 equals 3. Bring down the 4. Does 3 plus 4 equal 5? Not a true equation. 3 plus 4 is 7. This equation is no longer true. What if I only divide 4 by 2? 4 divided by 2 is 2. Bring down the 6. Does 6 plus 2 equal 5? Nope. Still a false equation. 6 plus 2 equals 8. Let's look at that definition one more time. It says to divide both sides of the equation by 2. Okay, so that means everything on the left side is divided by 2. So that means dividing 6 by 2 and 4 by 2. Because remember, 6 plus 4 is 10. We need to divide that whole thing by 2. 6 divided by 2 is 3. 4 divided by 2 is 2. Does 3 plus 2 equal 5? Yes, we finally have a true equation. So again, looking at our definition, it does say all terms. That means we have to divide everything in the equation by 2. No term is left behind. Final example, and the most complex equation. 6 plus 4 equals 12 minus 2. My left side has been separated from my right. Okay, both of these have a value of 10. I decide to divide the left side of the equation by 2. 6 divided by 2 is 3. 4 divided by 2 is 2. And the left side of the equation now has a value of 5. That makes sense. 10 divided by 2 should be 5. To keep this equation true, I'm also going to divide everything on the right side by 2. 12 divided by 2 is 6. 2 divided by 2 is 1. And 6 minus 1 is 5, making this equation still true. And there you have it, the 4 properties of equality: APO, SPO, MPO, and DPOE. We're going to use the properties of equality this week to create what are called equivalent equations. But going forward, these are the proper tools we use to solve equations. That's it for today's lesson. I will see you next time.